Okay, boys and girls, today we're going to review rules of exponents. Most of you probably have you learned this in a previous math course, but I just want to kind of review. So let's start by looking at a basic exponential expression. Normally we have a number before the expression, and that number is called the coefficient. And then we have a base. The base is the number that's being multiplied. So that would be our x. That's our base. I thought that was a highlighter, and it's not. So this is our base. And then our base tells us what's being multiplied. And then the last thing is our exponent. And our exponent tells us how many times the base is being multiplied. So this is my exponent. Okay, so here's the rule for multiplying. When we're multiplying expressions with the same base, we add the exponents. And so if I were to write that in words, it would say something like multiply the coefficients, because we always treat coefficients under general rules, under the rules you've learned before. So we want to multiply the coefficients, and then we add exponents of expressions with the same base. I guess I should say same basis. Okay? So if they're both x's, then we're going to add all the exponents of the x's, all the exponents of the y's, so on and so forth. So in this first example, our coefficients are 1. So we multiply those to get 1. Our bases are x, and our exponents are 4 and 5. So we're going to add the 4 and 5 together to get 9. In our second example, our coefficients are 3 and 4, so we're going to multiply that together to get 12. And then we're going to have x to the second times x to the sixth. Since they have the same basis, we're going to add exponents. And same thing for the y's, but we have to remember, because there's nothing there, it's understood to be a 1. So 1 plus 3 is 4. Okay? All righty. Once again, we're going to multiply coefficients. Negative 4 and 2 is negative 8. X times x cubed, they have the same basis, so we add their exponents, which gives us x to the 4th. There are no other y's, so the y squared just comes down. You can multiply anything, so just by writing them next to each other, that indicates multiplication. The coefficient is 1, so 1 times 4 is 4. Then x has an exponent of 1. We add those together, we get x cubed. Y has an exponent of 1, so we get y squared, because this one also has an exponent of 1. And then y1 times, z to the first times z cubed. We add those exponents, and we get 4. Okay, so when we're dividing expressions with exponents, what we want to do is we want to divide coefficients and subtract exponents if bases are the same. Okay. So in this first one, our coefficients are 1, so that's just going to be 1. And then 5 minus 4 would be x to the first power. All right, and the second one, I'm going to divide my coefficients, which is 9 divided by 3, which is 3. And then this is x to the third over x to the first. So I subtract my exponents, that gives me x squared. And then this is y squared over y to the first. Subtracting my exponents, that just gives me y. 25 divided by negative 5 is a negative 5. And then we have x to the fifth times x cubed times y to the fourth over y cubed. And we just added another person into it, and that's just z. And we're just going to leave it alone because it doesn't have anything, nothing at the bottom has the same base. All right, so 5 minus 3 is 2, so that's x squared. 4 minus 3 is 1, so that's just 1, and then the z just stays. Last one in this example, we have 3 over 12. That's 1/4. And if you're not getting that, you should calculate it, but generally we want to keep that as a fraction. And then 1 minus 5 is x to the fourth. 9 minus 4 is 5. And 3 minus 2 is 1. I am so sorry that my throat is itching. So when we raise a power to a power, we raise the coefficient to the appropriate power. And multiply exponents. Okay, so the first one, the coefficient is 1, so that's easy. And then we have x squared to the cube. We're going to multiply the exponent, so that's going to give me x to the sixth. I can write this as 3 squared x cubed squared. So 3 squared is 9, and x cubed raised to the second power is x to the sixth. For this one, we have to write this as negative 2 to the fourth, x cubed to the fourth, and then y to the fourth raised to the fourth. Okay, so negative 2 to the fourth, we've already done that. We said it was 16. And then we're multiplying those exponents, so that's going to be x to the 12th. Multiplying those exponents, that's going to give us y to the 16th. All right, last one. Remember, we got to break this up. Negative 1 cubed, x cubed, y to the fourth cubed, z to the fifth cubed. And remember, we're just multiplying exponents. So negative 1 cubed is still negative 1. X cubed, because that's 1 times 3. And 4 times 3, which would be y to the 12th. And 5 times 3, which would be z 15th. All right, anything raised to the power of 0 is 1. And the reason that is because of the rule that we did a minute ago, the quotient rule. So if I have x squared over x squared, well, we all know that's 1. But why? Because I can do x to the 2 minus 2, which is x to the 0. Or I could do x times x over x times x and say that the answer is 1. So either way, however you want to prove that, anything raised to the 0 power is 1. And I shouldn't say anything raised to the 0 power. I should say any non-zero number raised to the 0 power. Because when we get to calculus, we start looking at numbers raised to the 0 power. Any non-zero number, let me specify that. Any non-zero number raised to the 0 power is equal to 1. Alrighty? So I want you to look at the difference between these two problems because I specifically did this. Notice this one is in parentheses. So because this is in parentheses, I'm raising the entire thing to 0, so this is 1. However, in this problem, y to the 0 is the only one, y is the only one that's being raised to the 0 power. So y, this is the only one that's equal to 1. The rest of that remains 2x. I hope that made sense. Alrighty, so we're going to do this the way we did before, but remember, anything raised to the 0 power is 1, so that's 1. So now we have 25x to the 5th, and we have y third over y third, and then the z just stays there. Okay, so y third over y third, we know that that's the definition of y to the 0, which is 1. So everything else remains. We just have that 1 in the middle, which of course we're not going to write. Last one, 3 over 15. We're dividing that. That's going to give me 1 over 5. X to the 5th and x to the 5th. Well, I have 5 minus 5. I have x to the 0. So that's 1. And then I have y to the 9 minus 9. That's 1 again. And then z cubed divided by z cubed. We'll see that that's 1 as well. So my answer is simply 1/5. Last page deals with negative exponents. So if you have an expression with the negative exponent in the numerator, it goes to the denominator and becomes positive. And the opposite of that is true. If you have a exponent in the denominator that's negative, it goes to the top and becomes positive. So how do I write that? Negative exponents in numerator goes to the denominator and become positive. Okay? So, I'm just going to do this step by step. Well, the first one you look at is well, there are no negative exponents in there. But if we do what we did before, and we subtract the exponents, we have 4 minus 5. That's x to the negative 1, which we all know is 1 over x by definition. But let me show you why that's true. Let's say I have 4 x's, and I divided them by 5 x's. That cancels, and we throw that term cancel around, but what it really means is divide to 0. So then I'm left with 1 over x. Okay? So for the next one, I do have 3 over 9, which is 1/3. X doesn't have anything it's dealing with, so there it goes there. But y to the negative 2 would go to the denominator and become positive. Okay? We're almost there, guys. Just bear with me. And I'm sorry for the clearing of my throat. All right, so 25 divided by negative 5 is negative 5. That rule applies to exponent. It does not apply to numbers. We treat numbers the way we always have. So this would be x to the negative 5 minus 3, which is x to the negative 8. Then we have y to the 4th minus, y to the 4th minus negative 3. Which will actually give us y to the 7th. Oh, I was trying to figure out where the negative 8 came from. So that's y to the 7th. And then z doesn't have anything, so it stays by itself. So my answer is negative 5, y to the 7th, z. And what happened to my 8, x to the negative 8? Went to the bottom. All righty. Sometimes my iPad freezes up on me. Okay. All right. For this one, we have 4 over 12, which is 1/3. X to the 0 is 1. So that x has nothing to pair with, so it stays at the bottom. Y to the 3rd over y to the 3rd is y to the 0, so that goes away. And then z to the 1st minus 2 is z to the negative 1, which is 1 over z. So now that z is going to go to the bottom, and that's the answer. All right, boys and girls, and that looks horrible. 1 over 3 x z. That may not look better, but rule for raising a quotient to a power. Basically, raise the numerator and denominator. Denominator. To the power. So we're just going to raise them both individually to the power. All righty? So this becomes x to the 15th over x to the 12th. And how did I get that? I just raised x to the 5th to the power, x to the 4th to the power, but we can simplify that, can't we? That's x to the 15th minus 12, which is x cubed. 9 over y to the 4th raised to the negative 2 is going to be 9 to the negative 2, y to the 4th raised to the negative 2. So remember, because the exponents are negative, a negative exponent at the top goes to the bottom. So this is going to be 9 squared. Y to the 4th goes to the top. That's going to be y to the negative 8. I'm just going to go ahead and multiply that out. I'm sorry, it went to the top, so now it's just y to the 8th. So that's y to the 8th over 9 squared, which is 81. This would be 2z to the negative 3, and this would be negative 5x cubed to the negative 3. All right, so remember, again, we can switch these because that's going to be negative 5x cubed to the 3rd power, and then 2z raised to the 3rd power. And we can multiply that out. That would give me 5 cubed is 125, and it's still negative because that negative is different than a negative exponent. We treat that the way we have all our lives, and then that would be 8 over z cubed. And the last one, that's going to be 2 to the 4th, x to the 0, because 0 times 4 is still 0, and then y to the 8th, over 3 to the 4th is, I can't remember what 3 to the 4th is. It's 81 times 3, 243. So it's 243 x to the 8th, y to the 8th. Okay, so then that becomes 24 over 23. I'm sure I could simplify 243. I'm sure I can simplify that, but life's too short. And then x to the 0 over x to the 8th is still going to be x to the 8th. And then y to the 8th over y to the 8th is going to be 1. So this is 24 times 1, 243 over x to the 8th, and we have it. So that is our review for raising a power to a power. I hope you found those rules to be helpful. If you like, here's a little activity. Well, if you're my student, you must do this activity at the end. If you double click on this in Google Docs, you can just take the answers and move them to the center column, to the appropriate center column, and then you're going to answer here what steps you use, whether or not you used, you put your answers in the last column, and in the middle column you write what methods you use. So multiply and negative exponents or something like that. Okay, have a great day. I will see you guys.